Imagine you're floating in a spaceship, and up ahead, silent and invisible, is a black hole. Your first thought might be that you'd feel a sudden pull, then a quick end, like falling off a cliff. But the real answer is far stranger than that, because what happens to you on the way in depends entirely on how big the black hole actually is. To understand why, you need one basic fact. A black hole isn't a hole in space. It's an object so dense that its gravity bends space itself. At its center sits something called a singularity, a point where our current laws of physics simply stop making sense. Around it sits an invisible boundary called the event horizon, the point of no return. Cross it, and not even light can escape. Here's where things get strange. If the black hole is small, say, only a few times the mass of our sun, falling toward it would be brutal almost immediately. Physicists call this effect spaghettification, a term popularized by physicist Stephen Hawking. Gravity pulls harder on the part of your body closer to the black hole than the part farther away. That difference in pull, called a tidal force, stretches you longer and thinner with every second, like dough being pulled apart, until you're reduced to a thin stream of particles long before you even reach the event horizon. But picture a completely different scenario, a supermassive black hole, like the one sitting at the center of our own galaxy, millions of times heavier than the sun. Because it's so much larger, its tidal forces are actually gentler near the event horizon. Physicist Kip Thorne, who won a Nobel Prize for his work on gravitational waves, has explained that you could cross the event horizon of a supermassive black hole without feeling anything unusual at all. No pain, no stretching, nothing marking the boundary. You just keep floating, watching your instruments, completely unaware you'd already passed the point of no return. That idea alone should stop you for a second. You could cross into a region from which nothing, not even light, can ever escape and not notice it happening. So what would you actually see during the fall? Here's another twist. According to Einstein's theory of general relativity, time and gravity are linked. The stronger the gravity, the slower time passes relative to an outside observer. If a friend stayed safely in a spaceship, far away watching you fall in, they would see you moving slower and slower as you approach the event horizon, your image growing dimmer and more stretched out, but never actually seeming to cross it. From their perspective, you'd appear frozen at the edge forever, fading like a photograph left in the sun. But from your own perspective, inside the falling ship, none of that slowdown would be noticeable. Your clock would tick normally to you. You would cross the horizon in what felt like an ordinary moment, even though, to the outside universe, you'd already vanished from view. This isn't a contradiction, it's one of the strangest confirmed features of relativity, two completely different, equally true experiences of the exact same event, depending entirely on where you're standing when you watch it happen. Now, what happens after you cross the horizon? Here the physics gets genuinely uncertain, and honest scientists say so directly. Inside a black hole, especially a smaller one, tidal forces keep increasing until you're eventually pulled apart completely, atom by atom, as you approach the singularity. For a supermassive black hole, that final destruction still happens, just later, deeper inside, after you've already passed the horizon with no way back. Here's the deeper twist scientists are still debating. Physicist Stephen Hawking also showed that black holes aren't perfectly eternal. Through a process now called Hawking radiation, black holes very slowly lose energy and mass over unimaginably long timescales, eventually evaporating completely. For a stellar-sized black hole, this process would take far longer than the current age of the entire universe. It's real, mathematically predicted, but almost impossibly slow. So here's the mirror to your own life, hidden inside all of this. Whether you'd feel your fall or not, whether you'd notice the moment everything changed or not, depended entirely on scale, on something far bigger than you, working according to rules you can't always perceive from the inside. Big transitions in life often work the same way. Sometimes you feel the exact instant everything shifts. Other times, you're already through it, already changed, long before you ever notice it happen. So next time you think about crossing some invisible line in your own life, A decision, a change, a point of no return. Remember the black hole. Sometimes the biggest shifts announce themselves violently. And sometimes, if the scale is large enough, you simply keep floating forward, change completely, without ever feeling the moment it happened at all.